right, hi you guys. This one video is we're going to do examples 7 through 8. So, first thing we're always going to do is plug in that value 0. Now, if you notice for this one, we are actually doing the limit as h approaches 0. So we would have x plus 0 for h minus x squared over 0. And if you simplify that down, you would get 0 over 0, which means there is more to do. Now in this case, if you look at the x plus h squared, this one, we need to expand to simplify this. So, in order to expand this, what you would have for that part is multiplying it by itself and doing FOIL. Now I'm going to go ahead and write down what we end up with instead of showing all those steps. I'm hoping we're pretty darn confident at foiling by now. So we would end up with x squared plus 2xh plus h squared and then minus the x squared all over h. So if you notice, when we simplify this, the x squareds go to 0. So we are left with the limit as h goes to 0. We're left with 2xh plus h squared all over h. So if you notice, all three of those have an h. Instead of just worrying about canceling and when you cannot cancel, I'm going to show you this way. So in the numerator, does everybody see how it has a GCF of an h? So when you notice that, we can now identify that this part goes to 1. So we are left with the limit, oh, there's a 0 there. The limit as h goes to 0 of 2x plus h. So now, when we plug in the 0, we get 2x. So in this particular case, it actually ends up giving us a function. So let's just talk about what we did. We plugged in c. We end up with 0 over 0. And our hint this time was that we were going to expand. And then we ended up, on this case, getting a function. All right, onward we go. Number 8. So we're heading to 0. We are going to initially plug that in for x. And if you notice, this gives us negative 1/2 plus 1/2. We would get 0 over 0, which means there is more to do. And in this case, because you notice we have a compound fraction, we would need to simplify with common denominators. That's what we would use to simplify this. So, if we are taking the limit as x goes to 0, if you notice, now this is the part that you need to make sure you're comfortable with. Do you see how we have that x plus 2 in a denominator? And we also have a 2 in the denominator? So then our common, let's just do it this way. Here's the good old words. We want to say our least common denominator, in this case, would be those two multiplied. So when we are doing the least common denominator, we need to multiply both the numerator and the denominator by that. So then what we have is we have the negative 1 x plus 2 plus 1/2 over x, and all of this is going to be multiplied to each part of that compound fraction. Now, let me see if I can show you guys what is actually happening here. So the very first term is that negative 1 x plus 2. Now when we multiply this by the common denominator, if you would notice, those go to 1. We are just left with the number negative 2. Now the next one, the 1/2 times the common denominator. These go to 1, and I am just left with the x plus 2. Now the denominator times the common denominator, you are left with the x times the common denominator. Now, what simplifying can we do here? Those 2's go to 0. We are left with, oh, here's something else. And we can go ahead and show you in this step. This x, let me show you the next step, just so it's clear. So we have x over x times 2, x plus 2. And this is what I'm going to show you. The x's go to 1. So we are left with, that's supposed to be an m. Let's try this again. Make it a little neater, Miss Landon. All right, the limit as x goes to 0 of 1 over 2 x plus 2. At this point, we can plug in our 0, and we get 1 over 4. So this is the limit. And again, since we had the whole, then we know it is discontinuous. Let's go ahead and write what we did. We plugged in c, we ended up 0 over 0. We actually did the least common denominator and got our value. And again, it was discontinuous. And our whole is at 0, 1/4. So that's problem 7 and 8. See you next time.